Welcome back, students. We're still binomial chapter, lesson 13. We're on D. 2 more to go. The main point of this, we've been working with the binomial formula. It works well for small sample sizes if the number of trials is, say, 8 or 6 or something. But once you start having bigger sample sizes, more trials, the formula might get a little tedious, especially the n choose x part. Think to yourself, if I had 30 choose 11, what that formula would look like and sort of the amount of cancellation actually calculating that thing. So there is a tool on StatCrunch to help us compute these. You're more than welcome to use this when you're doing homeworks and quizzes and things like that, especially, like I said, for problems with larger values of n and x. So here's the example. We'll go back to this Congress one in September of 13. Only 14% of Americans approved the job that Congress was doing. Pollster sampled 20 people, so we have 20 trials. Probability of success is 0.14, and we've already covered the binomial model is the model, so I won't repeat that here. This is a binomial problem. Give the values of n, p, and q. That's easy enough. Maybe we'll throw it over here in the corner. N was 20 trials, remember. P was 0.14, and q was 0.86. If there was a 14% chance somebody thinks Congress is doing a good job, then 1 minus is 86% chance that they're not. Part B, out of the 20 respondents, how many do we expect to support? Expect says calculate the mean. All it is just 14% of 20. So the mean mu for this problem, n times p. 20 people, we expect 14% of them to support Congress. So what the heck is this? 2.8, I think, right? Good. 2.8 people. Sort of embarrassing when you think about it. Only 2.8 out of 20 would support and approve of the way Congress is doing their job. Let's calculate the standard deviation. Sigma equals, for binomial, square root np and q. Please, students, these are the formulas when we have a binomial situation. Not when we have data, not when we have a normal situation. So remember that the formulas go with the specific probability model. Let's crank it out. Big square root. Let's see, we'll do 20 for n times 0.14 times 0.86. N times p times q square root. I have no idea what that is. I got it here though. It's about 1.55. That's in people as well. Keep in mind the standard deviation is the same units as what we're talking about. So there's your standard deviation. Certainly we can get a sense of what would be unusual. Would it be unusual to have 4 people support out of 20? Not really. Would it be unusual to have 18 people? By the standard deviation and thinking about that, of course it would. All right. Part D then, down at the bottom of the page. A pollster comes home from work one Saturday and is surprised because 10 of his 20 respondents said that they support Congress. A pollster comes home from work and is surprised because 10 of 20 said they support Congress. Write out the binomial formula, but then we'll switch to StatCrunch to go ahead and get that answer. All right, so you're welcome to use the formula. I'm just saying there are other resources available. Probability x equals, we want 10 people, so probability x equals 10 is going to be 20 choose 10, 20 people, and I've got to get 10 of them supporting or approving Congress. P raised up to the 10 power, so this is 0.14, probability of success raised up to the 10 power, and probability of failure, 0.86. If I have 20 people, I've used up 10 to approve Congress. That leaves me with how many left over? I'll just put the 10 here. Those have to add up to the number of trials, so 10 successes, 10 failures. And that's the formula. By hand, this starts to get a little dicey, so let me show you the shortcuts. Over to StatCrunch. Pause the video if you're not logged on, but definitely do what we're doing here. All right, clean up the board, turn the lights down. I have the clapper, the lights just go off. Thank you, Kim. At the bottom of the page, you can see the instructions. You'll go to the stat button. I'm going to pull it up in just a second. Calculators and then binomial. We've been in there before. We've done stat calculators and normal. Okay? You put in exactly what you think you would. It'll need to know the number of trials, probability of success, and basically what do you want? X equals 10. Remember one thing for this problem, we only expect 2.8 people out of 20 to support Congress, and to get 10 would be exceptionally rare. All right, so StatCrunch. We're logged in. You can open up any data set or just open up a blank StatCrunch. The tool will be there either way. I picked a blank one here. And to get there, we'll go to the stat button, calculators, and binomial. All right, fire that up. Let's see what this thing looks like. I haven't been in here in a while. Really easy to use, just fill in NP and X. So for this problem, we have 20 trials. I change N up to 20. Probability of success, only 14%. Under the P probability for X, they give you all kinds of gizmos here. Less than equal, greater than equal, strictly less than, strictly greater. We want equals. We want equals 10. Up top, they give you a betweener option. We're doing standards. We don't need to do the between, and I hit compute. The picture that you're seeing is like a binomial histogram. It shows you where the probabilities are accumulating. And so the tallest bar at 2 here goes all the way up to about 25%. That's telling me that it's most likely for me to have 2 people out of 20 approve Congress. And then 3 is also very popular, right? It's very likely to get 3. And as you get to these big numbers, it starts tapering off. Down here at 10, there's a dot in the video. We probably can't even see it, but maybe on your screen. That probability, that little single dot there, is this 0.00011827. And what is that? So that number, that's the answer to the question. How many zeros? 1, 2, 3 zeros? And then a 1, and who even cares about the 1 after that? Yeah, that's correct. There's 3 zeros and then a 1. So what's the chance I get at least, or not at least, but exactly 10 out of 20 supporting Congress? This is quite rare. In fact, this is like 1 out of, this would be 1 out of 10, 1 out of 100, 1 out of 1,000. It's 1 out of 10,000 chance. And one thing I've been trying to impart on my students more and more is when we get these tiny numbers, I like to write this out like this. That's really unusual, 1 out of 10,000. You might just look at the decimal and say, oh, that's pretty unusual, 0.0001, but it's a 1 in 10,000 chance. So very unusual to get 10 people supporting Congress. All right, so that's how easy it is to use. And you can imagine in your head different scenarios, like what's the chance at least 10? Then I can use the tool to sort of, I want to say shade up. That's like normal model talk, right? Shade up or shade down. It's the same idea for binomial, even though there's these jumps. Only goes from 2 to 3 to 4 people. All right. So I guess part E down there at the bottom. Let's see here. I think I'm going to go back to the slide for one little second. I'm going to write a few things down. And so part E then says, what is the probability that a pollster has at most 3 people supporting Congress? At most 3. Write out the probability notation or the binomial and then use StatCrunch to get the answer. Let's make sure we're going in the right direction. At most 3 means 3 and that way. So 2 or 1 or 0. Blah, 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 blah. This is sort of what can happen. I can have up to 20 people say, I mean, that'd be so unusual, but at most 3, make sure you're shading down, counting down, right? I know that at most makes you want to go up, but just don't do it. Binomial, probability x is less than or equal to 3. Please just pause the video and look at this compared to at most 3 and see that that's correct. And so look at it until you got it. All right, at most 3 less than or equal to 3. This, boy oh boy, this would be x equals 0 plus probability x equals 1 plus probability x is 2 plus probability x equals 3. By hand, you're doing binomial formula 4 times, none of which are particularly delightful to calculate by hand, and then you're adding up 4 of them, right? This is binomial formula 4 times. And by all means, crank it out by hand, be my guest. I go to the calculator on this, right? So, get this in the notes. You can even, I mean, for fun, I'm not going to, but you can write the binomial formula out. At this point, I'm presuming you can do that. So, StatCrunch. X out of that, go over to the computer here. I've got the binomial tool still up. Double check, it shouldn't have changed, but n is still 20 for this problem. We're working with Congress. P is still 14. We want at most 3. Change the 10 to a 3 there. Be careful. The tool gives you less than or equal to, and the tool gives you less than. If you pick less than, it's only going to go 0, 1, 2. Because it won't include the 3. I need to do less than or equal to for it to include the 3. All right. Hit compute. Seems like it gave us the answer already. I like the tool. It actually shades in red what we're counting up. So here's all the 3s, 2s, 1s. You can see in terms of probability, this is a good chunk of the total. Right? It's just about 70%, 69.5%. And so there's pretty good odds that if we sample 20 people, that at most 3 of them would be supporting Congress. So probability x is less than or equal to 3 is equal to about 0.0696 or 69.6% chance that at most 3 people approve Congress out of 20. Couple more, letters F and letters G on the back, same example. Let's see what we got here. Give the probability that at least 5 people support Congress. Write out the notation. Well, I'm going to make the camera person work here. I'm going to go back to the slides. We're only taping them once, we might as well get the thorough presentation of the material. Part F, give the probability that at least 5 people support Congress. Remember, we're still talking to 20 randomly selected people. At least 5. All right? I could have 0 people support 1, 2, 3, 4. Well, at least 5. There's the line, right? And 6 and 7 and 8, blah, blah, blah. Boy, you do binomial formula on this one, a lot of work. I'd probably do complement rule myself, but either way, this is just a mess. So probability that x is at least 5. Reading carefully, the 5 is included, right? 5's included, I go like this. Probability x is greater than or equal to 5. This would equal, one way to do it would be get the probability x is 5, add to it the probability that x is 6, add to it all the way down to x is 20. Holy cow. Now, you could do complement rule and sort of tally up all of these. It's still 5 to add up and then do a 1 minus job. But guess what? We've got that tool, so let's just make our lives easier. This technology is a good thing. That's why the emphasis in the course is, understanding what everything means. And this is exactly one of those instances. All right. So we're on F, I believe. Probability x is at least 5 people support Congress. We still have n equals 20 people. Probability of success is still 14. And double check this. Yep, at least 5. I changed the x to 5. I'm picking out of the symbols greater than or equal to. If you put greater than 5, it's going to start counting at 6, and then your answer will be wrong. So there we go. Shades have been red. The graph that StatCrunch is presenting seems to stop at 10 every time, even though it goes to 20. But there's like no probability up there, so it just said the heck with it, and it didn't even make the graph. Like this is StatCrunch telling you that there's no chance you get 11 or 12 people supporting Congress out of 20. Answer is a .1375 rounded. And so there's, about a 13.75% chance that at least 5 people support Congress out of 20. You can do this, students. It's a good little tool. These are satisfying problems. You get the right answer, you feel good about yourself. Last one at the bottom, part G. I won't go back to the slide here. Determine the probability that a pollster finds 2 or 3 people that support Congress. So 2 or 3, probability x equals 2 or 3 is exactly probability that x equals 2 plus, whenever we see or, it's plus probability x equals 3. There's 2 ways to tackle this. I don't even know about the second way, but I see the betweener and I'm dying to use it. One way is I can get x equals 2. I change the symbol to equals, I get 2. I get the number, I write the number down. Put it here. Then I separately get x equals 3, get that probability, write it down, add the 2 results, and I'm home free. That curiosity is killing me. I gotta hit this betweener button. All right, betweener. Oh, how easy is this? Check this out. They give you the less than or equal to's. So all we have to do is just put 2 and 3 in here and we're home free. All right. Squeeze it in the middle. There's a 2. There's a 3. Check out the picture. It shaded the 2 and the 3. I mean, how slick is that? Use this to your advantage. I've got an answer of 4875 rounded. Same thing in my notes. Feeling good about it. So this is 4875 rounded, and to finish out this lesson. Oh, it's sort of depressing, but if you ask 20 people, there's about a 50% chance, roughly, that only 2 or 3 of them are supporting Congress out of 20 people. It is what it is, but that's the correct answer from a statistical standpoint. Practice with this. I would say go back in the notes and try a couple of those, the NHL shootout examples, see that you get the same answers when we use the formula. All right, so thanks for watching. One more video to go in this lesson, and we will see you in class.